Welcome to our next unit, all about logic. We're going to be exploring truth tables and how to analyze arguments in this lovely unit. Very useful in the real world when you're trying to read legal documents like wills or contracts, which I'm sure most of you will have to do at some point. Always good to have a lawyer there to read it, but it's also good if you can read it yourself and understand what it's saying. So learning the wording and how to analyze whether an argument's valid or not be very helpful in your life. Okay, so we're going to start out with just some definitions and some basics about symbolism in 3.1, and then we'll move into, jump it right into doing truth tables in 3.2. Okay, real quick brief history on logic. Logic is actually a study. It's part of math, but it's also its own. It stands on its own too. The first that we know of to systematically study logic were the Greeks. Aristotle is well known for that. We have Aristotelian logic. It tends to be very wordy, but he was actually sat down and systematically thought about, like, well, how do you make statements and how do you make arguments and things so that they follow a certain structure and make sense in the brain. And I think about Spock when I'm studying logic. That is illogical. Alright, Aristotle lived a long time ago, 384 to 322 BC, and he put his work together, and it was called Organon. Since then, there's been some folks that lived a lot later after Aristotle that stood out in the history of logic. There was a man named Leibniz, who was the first serious student of symbolic logic. Often when things are too wordy, it can be hard to be clear. It can be hard to, sometimes statements and words can have double meanings or just not be clear enough for us to be able to make determinations about the argument, whether it's a fallacy or valid, that kind of thing. So he was a student of symbolic logic, and that's what we're going to be doing a lot of focus on. Putting statements into symbols and then setting up truth tables and trying to analyze them that way, rather than trying to get tangled up in our heads with it. So he had a conviction that all mathematical and scientific thought could be derived from this organized way of thinking. And even today, mathematics, something isn't held as absolutely true unless you can form a logical proof for it. And you have to be able to prove that it's true for all cases. So, another gentleman that lived well after Leibniz, but ended up being called the founder of symbolic logic, which is kind of odd because Leibniz came first, but he just did so much impressive work that they would have called him the founder. George Boole. If you study computer programming, you'll hear about Boolean logic. So that's what it's named for. Alright, so let's jump in and start looking at some basics of symbolic logic. We're going to be looking at statements. These are going to be sentences that can either be designated as true or false. So we're not going to be doing any fuzzy logic here. It's all going to be true or false. And a simple statement can be symbolized with lowercase letters. Typically we use P, Q, and R to do this. You could use other letters too. There's nothing wrong with it. But you'll see P, Q, and R used a lot. A simple statement just conveys one idea. So an example of a simple statement might be something like, look out the window, oh, the grass is green. That is a simple statement. And I'm going to write in black, not in green, but so example one, you might say, well, let P be the simple statement that the grass is green. And then you might say, well, let's let Q be the simple statement that the sky is blue. These statements on their own can be designated as true or false. And of course, whether they're true or false really depends on the situation. P, the grass is green. Well, look out the window right now, and yes, that's true. Ask me again in 3 months, and it's probably going to be false. But so you have to look at your conversation or your situation to decide on the truth. Then the compound statement takes simple statements and puts them together to convey more than one idea, joined by connectives like and, or, if, then, if and only if. So for example, you might say, the grass is green and the sky is blue, or the grass is green or the sky is blue, or if the sky is blue, then the grass is green. So put them together that way and have compound statements. So let's start looking at what exactly can make compound statements. First of all, let's look at negation. I'm just giving you a brief overview here. Keep in mind, later we're going to go into much more detail in future lessons. So if I go quickly, don't worry. We'll be going back over this stuff later. Okay, negation changes the truth value of a statement. And this is right away where you can start getting tangled up in your head. And that's where really using symbols and rules will help to keep things untangled and logical. In symbolic form, the negation of a simple statement P would be written and has that little squiggly, you just say negation P, and you could read it as not P. Negating a statement with words like all, some, and none are a little trickier. We'll address that in a minute. But back to our grass is green scenario. If you have P is that the grass is green, and let's say that's true. I can then negate that, not P. I can say the grass is not green. And right now I look out the window, and that's false. Of course, that depends on whose house it is. My apartment complex happens to have very green, lush grass. So then by using that word not in there, I've been able to change the truth value of the statement. And that's the key, is changing the truth value. That's what negation is all about. So even if it started as false, you can change the truth value to true by negating. So it's not always let's say you have R, and let's say that making a simple statement about my son, Simon, and let's say I say Simon is 9 years old. This is actually false right now. So if I want to negate it, I can say Simon is not 9 years old. So just by introducing that word not, and then I can change the truth value. And now I've changed the statement to something true. So negation can go from true to false or false to true, either way. Now, as far as those quantifiers, be really careful. Like the example I just gave you did not have any quantifiers in it. It was just a very direct, basic statement. But if you start using words like all, some, none, be careful. Actually, today I faced this on Facebook. Hey, real life example here. I'm part of a forum for a certain genetic condition that my son was born with, and hearing from me. And a mother made a statement that she, paraphrasing, she essentially said that, all mothers, if they're allowed to get off the bed, can deliver a baby even if their skull is fused or not. And I commented on her comment and said, you might want to remove the quantifier all, because for me, I was allowed to move around and not just be stuck on the bed, and I still couldn't deliver my baby because his, a fused skull doesn't fit through your hips. It's not happening no matter what position you take. And she got huffy. People don't like to be corrected, I know, but I just couldn't help myself. Like, I'm just that teacher, But, yeah, you have to be careful using words like all. Do you truly mean every single one? And if you don't, then that makes your statement false. So you gotta be really careful. So let's say you have a statement like all birds can fly. Think about that for a second. That statement by itself, is it true or false? And of course, if you ask a 2-year-old, they're going to say that's true. But we're older, we know, well, that's actually false, because penguins don't fly. They look like they're flying in the water, but they don't actually fly. Ostriches don't fly. So there are birds that can't fly. So saying all birds can fly is false. But if I wanted to negate that statement and change it into something that's true, it's not as simple as just putting the word not in there. I can't say all birds cannot fly, because that's not true either, because there's a lot of birds that do fly. So either way, just adding not in there didn't negate it, didn't change the truth value. So I have to find a way to change the truth value so that negating all birds can fly will change it from false to true. So we have the word some. By saying we can negate and say cannot, so we can go from can to cannot. That is going to be part of it, but not all of it. And we're going to change all to some. So changing the truth value and changing the tone too. You know, going from a can to a cannot, but we have to change the word all to some. By saying some birds cannot fly, now we're speaking truth. Because that's acknowledging the penguins and the ostriches out there that cannot fly. But it's not saying that all of them can't, because that's still allowing for the ones that can. There's a little chart to help you to choose how to negate a statement with a quantifier. All is a pretty inclusive, extreme word. And well, seemingly on the opposite end of the spectrum is none. You know, people think, oh, all and none are like opposites. When you're negating, you can't go back and forth between those. What you're going to do is, like, if you have the extreme all inclusive, you're going to tone it down and say some. And then if it's all are, you're going to say some or not. Or vice versa. Some or not, you can negate by saying all are. And none, that's pretty extreme. None are. And it's appropriate, but let's say you wanted to negate that, change the truth value. You can't go to all, because that's, as we just saw with the bird example, it doesn't work. So you can go from none to some. So all are, some are not, go back and forth between those two to negate. None are, some are, go back and forth between those to negate. Alright, so for example, let's say that you have a statement like, pulling from the book, you know, you have all horses have manes. And I'm embarrassed to say I don't know enough about horses to know whether this is true or not. I'm going to assume it's true, but I think. But is there some, I don't know, is there some random breed out there that doesn't have a mane? I shouldn't have admitted that, huh? Alright, negation. Pay attention to the all. And instead of saying all, say some horses. Oops. Horses do not. Some do not have manes. And then if the initial statement was true, you've now guaranteed that you have a false statement. Or if the initial statement was false, you now guarantee that you have a true statement. Let me rewrite that, because I'm going to be posting these slides later, and I want to make sure people can read it. Sometimes this pen gets a little tricky. There we go. So go from all to say some do not. Or let's say you have a statement like, some teachers are professors. And you want to negate that. Remember our little chart, you can go all are to some are not, but you can go from some are to none are. You can say, no teachers are professors. And that negates that statement. Just be really careful there. Follow the chart. Don't try to second guess. Don't try to get tangled up in your head thinking about it. Just follow the chart. It's so much easier. Alright, now talk a little bit about some of the compound statements. A conjunction is a compound statement joined by the word and. They could, instead of saying and, say but. However, nevertheless, all of those indicate a conjunction. Notice the symbol there. Looks to me kind of like a capital A without the little bar through it. So like, let's say you have the grass is green and the sky is blue. Those are simple statements from earlier. The grass is green was our simple statement P. Let's say we want to join it with Q. and the sky is blue. And now we have a compound statement called a conjunction. So symbolically it's P and Q. If you see neither nor, just a little note, the neither nor statement is actually a conjunction. I know it sounds kind of weird because you have that nor there, you're thinking there's an or, but neither nor actually translates in logic to negation of the P and negation of the Q. So if you say neither the grass is green nor the sky is blue, that's the same thing as saying the grass is not green and the sky is not blue. So it's essentially a conjunction. So just keep that in mind when you're doing your problems. A disjunction, compound statement joined by the word or. Oops. The or is inclusive rather than exclusive, and the symbol looks like a V. So you have the grass is green. There's your P. Or the sky is blue. Which I've never walked outside and had it be either or personally. It's like, but anyways, I'm just giving you a rough example. So P or the V shape, Q. And we'll get into the truth values later. I'm not going to go into that right now. When we get to truth tables, we'll talk about the truths and falses. Conditional. Conditional statement has the words if then, and the part that's with the if is called an antecedent. The part that follows the then is called the consequent. That sounds like consequence, like result. You might have, I'm going to use this example later quite a bit. I'm going to say, if Simon makes an A in math, then he will get a bow and arrow. Bow and arrows. Okay, so let's say Simon makes an A in math is like a P statement. If then is used with a single arrow pointing to the right, then he will get a bow and arrows is the Q statement. So this is a conditional statement. The condition is the part with the if. The condition is that Simon has to make an A in math. That's the condition I've set forth. If he meets that condition, then the consequence, antecedent, ante before. So to come before the consequence, the antecedent, Simon has to make an A in math. That's the condition that has to be met. If he meets that condition, then the consequence will be that he'll get a bow and arrows. Okay? So this is one of those things where it's only contingent upon that condition being met. So if he doesn't meet that condition, if he doesn't make an A in math, then I don't have to get him a bow and arrow. Now, if he doesn't make an A in math and I still choose to give him a bow and arrow, that's okay. I'm just not obligated to. But if he meets that condition, I'm obligated to follow up and give him what I promised. So that's a conditional statement. And we'll get into those heavily too. And then you got biconditional. A biconditional statement has the words if and only if. Has something like a number is even if and only if and only if it is divisible by 2. So you have P, then you have what looks like a conditional arrow pointing both ways, Q. P if and only if Q. The statement is true if both have the same truth value, false if both have different truth values. So right now I could say if a number is even, then it is divisible by 2, and if a number is divisible by 2, then it is even. That's what an if and only if statement is. It's an if then that goes both directions. So hence the arrow that points both ways. And if I negate it, I could say if a number is not even, then it is not divisible by 2, And if a number is not divisible by 2, then it is not even. And in doing that, changing the truth value of both, but having the if and only if, I still have a true statement overall. If I change one of the truth values, not the other, then my statement's not the same. If I say if a number is not even, then it is divisible by 2. If a number is not divisible by 2, then it is even. Just those two don't make sense. So they both have to have the same truth value in order for the overall statement to be true. Then you're going to be asked to put statements into symbolic form. You're going to be asked to analyze them. There is a certain hierarchy, an order of operations, if you will, just like in algebra and just like in set theory. If you see a statement in words and you see commas, the commas are an indicator that you're going to have to group things together. Group the stuff to the left of the comma, group the stuff to the right of the comma. Grouping requires parentheses. Then when you're trying to determine a statement's truth value, always look inside of parentheses first. That's true in math, sets, logic. Parentheses first. And whether you're working inside the parentheses or don't have parentheses, you look at negations, then you look at conjunctions and disjunctions. Probably good to just go from left to right. Then conditionals, and finally biconditionals. Your statement might not have all of those, but you still follow that order for what it does have. But if it does have all of them, then definitely follow that order and see where you end up. And whatever you end up analyzing at last, that is the type of statement you've got. Okay, so let's look at a quick example here of something you might face in this homework. Writing something in symbolic form. You might have a statement P. The chili is spicy. And you might have a statement Q. The sour cream is cold. I'm actually pulling this from page 99 in the textbook. Current textbook. 10th edition. If you have something like that, and let's say you have a statement that says if the chili is spicy, then sour cream is not cold. Okay, so you have an if-then statement, so you're going to need the arrow. The antecedent, the chili is spicy. Well, that's statement P. Took care of the if-then. So a comma here, I'm like, I need to look carefully. If there's anything compound to either side of the comma, I'm going to have to group it in parentheses. But I might not need to do that here. The sour cream is not cold. Q was the sour cream is cold. So that's actually the negation of Q. If you really want to, you can put Q and not Q in parentheses. But you don't have to. Because in the order of things, not Q would be handled before the conditional arrow anyways. So you don't have to have the parentheses there to force it. But if you had something else going on, like an and or an or something over here, you would definitely need parentheses to group it together. This comma tells you to do that. If you see something crazy like it is false that, I'll show you how to handle that. Or it is not true that, same thing. It is false that the chili is spicy. Or the sour cream is cold. I don't feel like making a whole new line, so let's put that here. It is false that automatically gets a negation parentheses. So if you say it is not true that or it is false that, automatically put negation parentheses and then put the rest. The chili is spicy, P, or this little V symbol. The sour cream is cold, Q, close parentheses. Okay, so that, yeah, it is false that or is not true that. Be aware of what that looks like. Alright, let's say you have something like, let's do one more example. Let's do one with 3 statements. I'm going to flip over to page 100, I think. Yeah, I'm going to flip over to page 100. Let's say you have a statement P, that the water is 70 degrees. Let's say you have a statement Q, that the sun is shining. And let's say you have a statement R, that we go swimming. So we have all that. And this time, instead of having a statement in words, let's say they give us the statement in symbols, and then we have to put it in words. So something like, let's see, I want to make sure I include one with parentheses so you guys can see this. Let's say we have parentheses, Q and R, close parentheses, conditional arrow to P. So yeah, something like that. It's actually number 62 on page 100 in the 10th edition. Alright, so we tackle the parentheses first, Q and R. So Q is the sun is shining. And R is we go swimming. Okay. But then I see a conditional arrow. Ooh. So this whole thing is the antecedent. So I'm going to need an if. I could probably not have that capitalized. If the sun is shining and we go swimming, comma. Then P. The water is 70 degrees. So watch out for that. You see the parentheses there. It's saying make sure that whatever's here is grouped together, and often a comma is a good way to group it. So that way everybody knows, oh, okay, all of this here is the antecedent, and then the water is 70 degrees is the consequent. So there you go. So you have quite a few of those to practice. Definitely, make sure that you know all this terminology, know how to go back and forth between the words and symbols. Because in 3.2, when we get to truth tables, you're going to be working with symbols quite a bit. So you're going to have to be comfortable with what symbols to use where, what punctuation to use where, because you have to set up the statements carefully in order to get an accurate truth table when you're trying to analyze your statements and see overall, are they true or false, and then if so, under what conditions. So practice, practice, and I will see you soon for the fun of T's and F's in truth tables.